In this example, we are given this graph, and our task is to determine whether it represents a function. If it does, then we will answer the following questions. First, does this graph represent a function? To answer this, I will use the vertical line test. The vertical line test says that if any vertical line intersects the graph more than once, then the graph does not represent a function. Now, imagine I have this vertical line and I am sliding this vertical line across the graph. Does the graph intersect the line more than once at any point? The answer is no. Therefore, this graph does represent a function. Question A, find the domain and range. Use interval notation. The domain is all the x values that we can use. The graph continues forever to the left and forever to the right with no breaks or holes. Therefore, the domain is all real numbers, meaning any x values is allowed. In interval notation, we use from negative infinity to positive infinity. We use parentheses with infinity. The range is all the y values that the graph produces. The lowest points on the graph occur when it touches the x-axis. At this point, y value is 0. And at this point, y value is also 0. The graph never goes below 0, and it increases without bound. Therefore, the range is from 0 to infinity, including 0. In interval notation, the range is from 0 to infinity. We use bracket at 0 because 0 is included. Question B. Find the zeros or x-intercepts and use order pairs. X-intercepts are the points where the graph touches the x-axis. This graph touches the x-axis at this point where x equals -1 and this point where x equals 1. This point is an x-intercept and this point is also an x-intercept. And we want to use order pair. So at this point, x equals -1, y equals 0. And at this point, x equals 1 and y equals 0. So the x-intercepts written as order pairs are -1, 0 and 1, 0. Question C, find the y-intercept and also use order pair. The y-intercept is a point where the graph crosses the y-axis. So this point is the y-intercept. At this point, x equals 0 and y equals 1. So my y-intercept in order pair is 0, 1. Question D. Find the intervals on which the function is increasing. A function is increasing when the graph goes up as we move to the right. Let's look at this graph and break it into parts where the direction changes. From here to here, the graph is going down. From here to here, it's going up. From here to here, it's going down again. And from here to here, it goes up again. That gives us 4 intervals. from negative infinity to negative 1, from negative 1 to 0, from 0 to 1, and from 1 to infinity. The graph goes up from left to right on this part and also this part. So the function is increasing from negative 1 to 0 and 1 to infinity. Question E. Find the intervals on which the function is decreasing. A function is decreasing when the graph goes down as we move to the right. The graph goes down on this part and also this part. So the function is decreasing on the intervals from negative infinity to negative 1 and from 0 to 1. Question F. Find the intervals on which the function is constant. A function is constant when the graph is flat. This graph has no flat sections, so there's no constant intervals. Question G. We need to look for symmetry of the graph. Since the left side of the graph looks exactly like the right side of the graph, so this graph is symmetric about the y-axis. Question H. We need to determine whether the function is even, odd, or neither. If a graph is symmetric about the y-axis, then the function is even. So this is an even function.